Now, if we are to compare two sample proportions this time, we just have one test, the z-test two samples. Sorry, that's not proportion, that's supposed to be means. Sorry, not means, but supposed to be proportions. Go. Proportions. There you go. Yeah. Now, if there's one thing that's a little bit difficult is that in Excel data analysis, there's no t-test two sample, z-test rather, two sample for proportions. So instead, we're going to use Excel as a calculator for us to compute the values that we would need. So I'll go to Excel for that. Alright. So now we have this example. A survey was conducted among 83 households in regions 2, 6, and 12 in the Philippines. One of the questions asked their type of household, whether they are just one single family, just the father, the mother, and his siblings, or they are an extended family with other relatives. At 0.05 level of significance, tests the claim that there's no difference in the proportions of single families in regions 2 and 6. Now, again, if you're going to look at data analysis, there is no such test for this. So, what we would be doing is we apply this formula. This is the manual formula for z-test of proportions, and then we use Excel to be our calculator. So, how do we do that? If you might have noticed, I have placed this one here because these are the one that corresponds to the formula. Unlike natural displays, Excel is a little bit difficult to work with because it's just one single linear display. Hence, for us to be not confused with so many parentheses later on, we would be doing it one by one. Here, for example, one of the things that we would need to get the sample proportions would be the sample sizes. So first, let's compute our sample sizes. How do we do that? We need to count these data sets here. And to count that those are not numbers, the formula in Excel for that is count 8. Count the number of cells that are not empty. So once we select that, we first select here. We don't select the cell with region 2 because that will also be counted, but that's just a label. Close and then enter. That means the sample for region 2 has a sample size of 38. For region 6, we also count it. Here only, close parenthesis, and there you go, 21. Now, we want to count how many has that single family count. So before we place the actual proportion here, let's first count how many. And since we're counting a number that is, we're counting a data that's not numerical, we use count it. So that we can count how many how many cells has the word single family. So we count if, then open parenthesis. Excel tells us how to write the formula, so it's easier for us. So range means this. There we go. Then after that, comma, as you can see, comma, and then we need the quotation mark, and then you type single family exactly as how the data is written, because otherwise it will not count properly. So there are 32 cells here that says single family out of 38. And that proportion is 32 and backward slash 38. That's the proportion now for P1. For P2, we do the same. We count how many from this range. There you go. Is type or has a data of single family. There you go. This times it's 17 out of 21. And to make the proportion is divide backward slash, that means divide. So there you go. Now for N1 P1, that's actually, if you're going to think of it, it's actually this two already. But just to be sure, N1 times P1, so that's N1, select at the cell for N1, asterisk, then P1. There, for N2, N2, asterisk, P2. This asterisk is multiplication. Why do I need N1 P1 and N2 P2 here in the formula here? We need that. Then we also need N1 plus N2, so going to 5 equals N1 plus N2. There you go. And that would be N1 P1 plus N2 P2 over N1 plus P1 is P1. So I forgot that. Let's paste that here. N1 P1 plus N2 P2. So that would simply be equals N1 P1 plus N2 P2. So P bar would be N1 P1 plus N2 P2 over N1 plus N2. There you go. This is our P bar. And we need 1 minus P bar in here as well because this is P bar. That's 1 minus P bar. So we're going to have equals 1 minus this. Okay. And in the formula, we need 1 over N sub 1 and 1 over N sub 2. So equals 1, backward slash N1, N1 equals 1, backward slash N2. And the sum of those two fractions is what we need to multiply to P bar and 1 minus P bar. So we're going to add this, and oops, if it's covered, you just select the cell. That's E20. So the product of this is the one inside the square. That's why I write denom square. So that would be P bar times 1 minus P bar times this one here. That's E20. Oh, and the square root of this is the denominator here. So for square, that's equals SQRT. That's the formula for square root. Square root of this. There you go. P1 minus P2, this becomes P1 minus P2. And finally, the Z, the test statistic Z would be equal to P1 minus P2 divided by this denominator here. There you go. Now, the formula that you see here is the formula for the P value of our test statistic. So let's have that. That's equals 2 times 1 minus, the formula here is, sorry, I forgot, that's norm. Norm dot S dot test here, sorry. Norm dot S dot test, there you go. You can actually select the formula so that it comes already. It needs the Z, so I select this cell, comma, cumulative is whether it goes, it's exactly just the Z or to the, also it goes to the left. Also, since we need that area to the left, we type close this, close that, and so there you go. Let's just fix this. The formula is supposed to be norm dot S dot test. So we have our P value here. And then now we can already perform our hypothesis because this has been steps 2 and 3. So here first, for our claim, to test the claim that there's no difference in the proportions in the families for regions 2 and 6. That means for our step 1, sorry, that bigger. So the claims that there is no difference. Difference. So that would mean that the proportion for region 2 is just equal to the proportion of region 6. HA is the proportion of 2 is not equal to the proportion of region 6, making this a two-tailed test. Now, with that in mind, this is already steps 2 and 3, and this is the p-value we have. So for step 4, the p-value of 0.74594 is obviously bigger than the alpha of 0.05. Hence, we have failed to reject HO. Our conclusion now is that there is no sufficient evidence to reject HO. Thus, the proportion of region 2 is just equal to the proportion of region 6. So let's have another example. Up. So pause the video and then try to see if we can perform a full hypothesis test of this problem. So, assuming you have done the hypothesis test, researchers found that 12 out of 34 small nursing homes have a resident vaccination rate of less than 80%, while 70 out of 24 large nursing homes have vaccination rates of less than 80%. At 0.05 level of significance, test the claim that there's no difference in those proportions. So luckily, the numbers are given. We don't need to count them, so let's just place them in 1. The sample size for the small nursing home is 24, while for the large, it's 24. The proportion is 12 out of 34, so it's 12 divided by 34, while the other one is 17 out of 24. So N1 is N1 times P1, the other one is N2 times P2. Then we add N1 and N2. Then for P bar, N1 P1 plus N2. Oops, sorry, we did not have that set yet. We did not have that one yet, so maybe I can just have it this way. N1 P1 plus N2 P2 divided by N1 plus N2, which is at cell P20. You can also do this. It's just that if you're going to wait for the entire Z, you're going to have a lot of parentheses. That's P bar. 1 minus P bar, give this. We're going to have 1 over N1, 1 over N2. Then we're going to add this in here. This plus P24. So square of the denominator is P bar times 1 minus P bar times this, which is P25. Hope this is not that useful. It's just the square root of it. So square root of this and go then P1 minus P2, P1 minus P2. So for our z-score, it's this divided by this. There we go. Let's copy the whole. So for the p-value, 2 times 1 minus norm. Next up this is the z-score. True, truth, close. There we go. Now we can perform our hypothesis test. So the proportions, the claim is that there's no difference in the proportions. So that means for our step 1, there's no difference, so that's equal. So the proportion of the small is just equal to the proportion of the large nursing homes. HA is obviously not 1. This makes it a two-tailed test. This is already steps 2 and 3, so step 4, obviously the p-value of 1.9923 is bigger than alpha of 0.05. So thus we have once again failed to reject HO. Therefore, our conclusion is that there is no sufficient evidence to reject HO. Thus, the proportion of the small nursing homes is just the same as the proportion of the large nursing homes. And that is Z-test to sample of proportions.